Autoclave. Introduction. The autoclave is an equipment used for sterilization. The word sterilization means the destruction or elimination of all forms of microbial life, including spores present on inanimate objects, by means of physical, chemical, or gaseous procedures. Laboratories should be equipped with a reliable autoclave of adequate capacity. Small health center laboratories require an autoclave mainly for decontaminating specimens and infectious waste. Purpose. In the laboratory, materials and objects are sterilized for the following purposes: to prepare materials for bacteriological cultures, such as test tubes, pipettes, petri dishes, etc., in order to avoid their contamination, and
to sterilize the contaminated material before disposal,
such as used culture plates, syringes, glassware, etc. Principle. Autoclaves work by taking advantage of the thermodynamic properties of water. Autoclaves use pressurized saturated vapor for transmitting thermal energy to elements that require sterilization. In general, this method is known as steam or moist heat sterilization.
When the pressure inside the autoclave is raised higher than the atmospheric pressure, the temperature at which water boils is elevated. For example, at 15 psi, that is pounds per square inch pressure, the temperature of steam reaches 121.5 degrees centigrade, at which all spores coming into contact are killed within 15 minutes. Mechanism of sterilization. Denaturation of critical protein and nucleic acids within the cell. Denser material like large dressing packages or large media bottles require extra time for the heat to penetrate up to them. This may be up to 30 minutes. Types. There are two main types of autoclaves. Gravity displacement autoclave. This is the most common and simplest type. It uses the heating element to heat up the water and to generate steam. The steam is then pumped into a chamber containing ambient air. Due to lower density, it rises to the top of the chamber and gradually displaces all ambient air, which is forced out through a vent below. The steam continues to be pumped at a higher pressure than normal atmospheric pressure, so it reaches a temperature of about 121 to 140 degrees centigrade. After the cycle, the steam is discharged through the exhaust valve. Advantages: this is a cheap method. Uses: for the sterilization of waste, liquids, and instruments. Disadvantages: this method is not effective where it is difficult to displace the trapped ambient air. For example, porous loads like bedding, wrapped goods, surgical packs. It takes a longer time, and at the end of a gravity cycle, the load can still be hot and possibly wet. Vacuum-assisted autoclave. The ambient air in the chamber is removed dynamically by a series of alternating steam pressure injections and vacuum draws, also called pulses. Drawing a vacuum to remove ambient air from the chamber allows the steam to be sucked into areas where it would otherwise have difficulty penetrating. Steam fills up the vacuum almost instantaneously. Advantages: it's quicker and keeps the load dry. It is a more reliable method for porous loads such as gowns, drapes, towels, etc. Disadvantages: it is an expensive method and not suitable for liquids.
Components. The main components of big autoclaves used in large hospitals are autoclave door and lid, sterilization chamber, thermometer, jacket, drain, chamber's manometer, safety valve. Operation: decontamination of specimens and infectious waste. Place the articles for decontamination in wide, shallow, leak-proof, solid-bottomed containers, not more than 200 millimeters deep. Do not cover the containers. When decontaminating infectious material in plastic bags, do not overpack the bags. Leave them unsealed with their tops folded back. Sterilizing culture media. Place bottles and tubes of culture media in wire or polypropylene baskets. Limit the amount of culture medium in bottles to 500 milliliters. Leave the caps loose. Tighten after autoclaving. Always sterilize the media at the correct temperature and for the correct length of time, as instructed in the method of preparation. Always sterilize the media at the correct temperature and for the correct length of time. Under autoclaving can result in an unsterile medium, whereas over-autoclaving can cause precipitation, lowering of pH, or the destruction of essential components in a medium. Sterilizing laboratory ware. After cleaning, prepare reusable items for sterilization as follows. Syringes. Wrap polypropylene, nylon, or glass syringes. Barrel alongside plunger in a clean cloth and close with adhesive tape or tie with a cloth strip. Lancets and scalpel blades. Wrap stainless steel reusable lancets and scalpel blades individually in clean pieces of non-shiny porous paper and place in a small tin or other autoclavable container. Sterilize with lid open. Close after autoclaving. Pipettes. Plug glass or polypropylene pipettes with non-absorbent cotton wool and wrap individually in non-shiny porous bag, example, X-ray wrapping paper, or place in a metal or polypropylene canister. Leave the top off during autoclaving. Specimen containers, tubes, petri dishes, and other laboratory ware. Place polypropylene and heat-resistant glass containers, tubes, and other items in wire baskets or other suitable open-sided holders. When loading, make sure the caps of the containers and tubes are loosened. Using a manually operated autoclave with thermometer and pressure gauge. Add the correct amount of water to the autoclave as directed in the manufacturer's user manual. When loading the autoclave, leave sufficient space between articles for the steam to circulate freely. Do not allow articles to touch the sides of the chamber or stand in water. Use a tray or wire stand in the bottom of the chamber. The weight of the load and description of articles should be noted down in the log. Place a control time steam temperature indicator strip in the center of the load where steam penetration is likely to be slowest. Secure the lid of the autoclave as instructed by the manufacturer. Open the air cock and close the draw-off cock. Heat the autoclave. If using an electric autoclave, switch on the power to maximum setting. Allow the correct length of time for all the air to be expelled as instructed by the manufacturer. Check whether all the air has been expelled. It is possible to check whether all the air has been removed from an autoclave by connecting one end of a length of tubing to the air outlet and immersing the other end in a container of water. All the air has been expelled when no more bubbles can be seen emerging from the tubing into the water. Close the air cock. This will cause the pressure to rise and with it the temperature of the saturated steam. When the required pressure has been reached, as shown on the pressure gauge, and the excess steam begins to be released from the safety valve, reduce the heat and begin timing using a timer. The heat should be sufficient to maintain the required pressure for the duration of the sterilizing time. Depending on altitude, set the timer. This chart gives the time and the temperature required for sterilization in an autoclave corresponding to the altitude. At the end of sterilizing time, turn off the heat and allow the autoclave to cool naturally. This will usually take several hours, particularly for agar culture media, to cool sufficiently for safe handling. When the thermometer reads below 80 degrees centigrade and the pressure gauge registers 0. Slowly open the draw-off cork to vent the autoclave. Open the air cork and wait for a few minutes before opening the lid. Important: to avoid fluids boiling and injuries from burns or exploding bottles, never open the draw-off cork or air cork or attempt to open the lid of an autoclave until the temperature has fallen to below 80 degrees centigrade and the pressure reads 0. Some models of electric autoclave are fitted with a safety device or a thermal lock that prevents opening when the autoclave is still under pressure. Open the lid of the autoclave as instructed by the manufacturer and carefully unload it. Check the process control strip to ensure sterilization has been satisfactory. Keep a log for autoclave use. An example is shown here. Customize according to requirements. Daily verifications. Autoclaves should be checked daily to ensure that required temperature and pressure are sustained during operation. Before initiating the sterilization processes, the following verifications will have to be carried out. Clean the front of the autoclave, controls, indicators, and handles with a damp cloth. Ensure that the cold water, compressed air, and vapor supply valves are open. Check regularly for signs of wear and damage. Examine particularly whether the lead seal gasket is flexible and undamaged and is not allowing steam to escape from the lid.
The power cable is undamaged.
The pressure gauge is in working order and reading 0 at atmospheric pressure. The safety valve is freely moving and in working order. The air cork and the draw-off cork are undamaged and working correctly with no leakage from seals. Test the condition of manometers and thermometers. Clean the inside of autoclave after use and also around the valve and stop corks. Make sure that the vent is not blocked. Do not use a corrosive cleaning chemical. Refer to Equipment Maintenance Module for a detailed description on maintenance of an autoclave. Calibration. Maximum period between successive calibration and checks should be 1 year. Check on effectiveness of sterilization with each cycle. Quality control. In order for a product to be considered sterilized, it is necessary to verify that all the stages of the sterilization process have been carried out correctly. Different categories of tests are sterilization process indicators. These are designed for supervising the functioning of the autoclaves. They include instruments that control parameters like temperature, time, and pressure and register the development of the process.
Chemical indicators. These are visual aids that show if an item has been subjected to the sterilization process. They change color or state, that is solid state to liquid state, when exposed to conditions of sterilization. Temperature-specific chemical indicators respond to high temperatures attained during sterilization. Autoclave or chemical tape is the most popular one. It has easily recognizable stripes made of heat-sensitive ink, which changes color from white to a visible pattern when exposed to temperatures commonly used in sterilization processes, typically 121 degrees centigrade in a steam autoclave. It allows identification of processed from unprocessed items at a glance without the need to open the packs or check the records. Though the color change in the autoclave tape indicates that the autoclave reached the right temperature, it does not confirm how long it was held inside the chamber. Multi-parameter chemical indicators or integrators respond to a combination of conditions such as time, presence of steam, and temperature, also called TST strips. These provide more reliable proof of sterilization. They come in the form of a paper strip, liquid in a vial, or a pellet in a packet. Biological indicators. These are considered the best methods to ensure and to document the success of a sterilization process. They are standardized populations of resistant bacterial spores, for example, Geobacillus stearothermophilus, which are killed if the sterilization cycle parameters are correctly attained. At the end of the sterilization, The spore tube and a positive control tube are incubated. Any color change or cloudiness in the original autoclaved vial indicates a failure of the autoclaving.
The suggested frequencies with regard to the use of quality control indicators in the sterilization processes are process indicators in each sterilization cycle, chemical indicators in each package, biological indicators weekly in all the sterilization equipment in the packets that contain implants.